Hello everyone, in this video we are going to learn about building our own robot using Webot. And at first, the texture background light and rectangle line are all has been imported. Now we need to create a robot. To create robot at first, we need to add base node, then use the robot. After that, we need to add a shape to our robot. If you follow the steps properly and carefully, you will create a robot on your own very easily by using robot. Then we need to add shape to our children. The base node should the base node should be shape, and in the children we have added base node as shape. Then we need to add appearance to see the shape, and I have used previous appearance. Then I need to add a geometry. I need to change the color first. This is going to be a long video. I need to change the metalness to give a more robotic feelings. Make it like a Tesla car or something nice like that. Then we need to add a geometry, and as the robot is shaped like a box, I have added box in my geometry. And you need to change the size of the box body of the robot based on your likeness, whether you like a big robot or whether you like a small robot. Change the value of x, y, z. You can use the similar value that I have used in this video. I have given this value. X is 105, y is 0.14, z is 0.4. Then I need to add the bounding of it so that the rest of the materializer object can identify this body shape. And I am giving a shape a name, body, defining this as body shape. After defining body shape, I can add the bounding object. I just use the body shape. You need to memorize this thing. At first you need to give the shape as a name, then you can add the bounding object. After that you need to add the physics. Now to add the 4 wheels, we need 4 hinge joints. We add the 4 motors, 4 rotational motors. In this robot that we are building, we are going to use rotational motors. Then hinge joint, we need to add hinge joint parameters in the device. For device, we will use rotational motors. We are giving the rotational motor a size, a shape, solid. Follow the steps carefully. Now in the input solid, and in the subsection children part, we are going to give it a shape. And the rest of the things are quite similar. We are going to add appearance and geometry as we have done previously before. Prepare appearance to give it a more like robotic feeling. As a color, I prefer black. You can give any color you want. And after that, adding the prepare appearance, we need to add a geometry. As it is going to be a wheel, we are going to give it a cylinder shape. After that, we need to change the height or radius to see the wheel. After some time, You can see the as the values are quite crucial to get a proper position with the body of the robot. So you need to be very careful while giving the values of rotation like x, y, z, and an angle. The values could be different for you or similar with me. The values totally depends on the position of the body, the robot, the size of the rectangular area, and many things. So as you can see, where I is starting to see a slightly smaller wheel. We have created just one wheel. We need to create four wheels. Just like slide the wheel to the end of your body of a robot. Yes, yes, like beautiful looking wheel I have created. Just slide it out of your robot body. And try to make the wheel as close as possible with the body to make it more realistic. After that, I am the same way. We are going to create four more wheels. This part, like if you want to, like you can see the video, just increase the speed of the video. You can just copy and paste this and just drag and drop or slide down. So it's a like quite easy process. After just create one wheel, just copy and paste the rest of the wheels. Just change the position to make it a proper element with the robot body. You can use the like red, green, and blue marker to like change the rotation or the position of the wheel, of the body or anything in your whole system environment. Try to make the wheel straight as straight as possible. You can see that the like back of the last wheel of my car is like quite up. This wheel is like it's not straight. So by rotating properly, you can straight the wheel. You can use the red, green, or blue axis, which means X, Y, Z, to rotate the wheels properly by clicking by using a mouse, and it's quite easy. Very easy way. We have just created extra two wheels, and we just need to create one spool. Also, you can change the values manually to give the wheels a proper element with your car with the body of the robot. And I'm changing the values manually. Like you can done it in easy way by giving a wheel a proper value, and for the rest of the wheels you just need to plus minus plus by adding plus minus, just you can change the position of the wheels. So it's also quite easy way. Just put a wheel in a proper position, and after that just change the signs of the values x, y and z. In this way, like the wheels will be in proper element, in proper position with the robot body. So you can see that I just change the values and giving it a minus or plus sign. The transition of the trace is similar. You just need to change the sign values. You can increase the speed of the video if you want. And lastly, we are creating a last wheel. The values are similar, thus I need to change the sign of these values. Yes, so I have just put an extra minus sign, and our robot card is created, and we can see 4 wheels has been connected with the 4 hinge joint points and 4 rotation motor. As we have created a line follower robot, we need to add 3 distance sensors for this purpose. So in the same way, in the children, in the robot shape, we are adding a distance sensor, and in the children of the distance sensor, try to understand the sequences, or you can pause the video here, try to understand the sequences. And in the children, we need to add shape to give a shape of the distance sensor, and we need to add appearance, give a reference to give it a more robot feeling and robot vibe, and adding a box to geometry, because I need to see my distance sensor as a box shaped sensor. And we can see that our sensor has been created, but the size of the sensor is quite big, as you need 3 sensors for the line for our robot, left, right and middle. We need to reduce the size so that we can accommodate 3 sensors in front of the car, as we are reducing the size of the sensors. Just I need to create one sensor is quite carefully. For the rest of the sensor, you just copy and paste and change the position. We're trying to reduce the size of the sensor so that we can accommodate 2 more sensors in front of the car. Introduced Now we're going to adding the coordinate system, and to see the sensor rays, we are adding sensor rays so that we can easily understand whether the sensor is working properly or not. Like after creating just one sensor, I have just copy and paste two of the sensors and just like slide it here and there to give it a proper position. Yeah, our car is ready, but to work properly, we need the rays should be pointed to the ground so that the sensors can see the line that will be created by using Tinkercad. So our car has almost completed, and we have created a car on its own from scratch without using a pre-built robot. This is a very big thing, and I think this approach will help you a lot. Also, we need to like change the type of the sensor to infrared. We need to change the type generic to infrared for all the sensors, or three of the sensors. As we need to like control the sensors and wheel, we need to give each of them a separate name. The distance sensors should have a different name, the wheel should have a different name, like ref, light, bottom. The sensors name should be distance sensor left, right and middle. After that, after giving the shape a name, we can use the name as a bounding object. After that, we need to add physics for all of the wheels and distance sensors. If you like forgot to follow any one step, the car will not work properly. So it's a very tough work, but you can understand the working properly, then it will be easier. And in the lookup table, I have changed the value so that the range of the ray should cover a bigger distance, as the distances are quite higher from the ground. So you need to increase the range of the distance sensors. And like the I'm going to do the similar things, like giving name to each of the sensors and adding bounding object and physics, and add physics. Easy simple things. Increase the in this way I am increasing the range of the distance sensor. The lookup table part. This is the distance sensor right. This is sensor right, this is the middle, and this is the left. Now we are going to like adding the bounding object and add physics. Increase the range of the distance sensor so that it would cover a huge area for the distance. So our work is almost completed. Now after like giving the distance sensor separate name, also we need to like control the rotational motor so that we can rotate the wheels properly. To do that, we also need to give each of the wheels a proper name to distinguish between the wheels. Each of the hinge joints should have different name in the rotational motor part, in the device and in the rotational motor part. Wheel 4, wheel 3, and so on. And to understand, you need to change the name of the rotational motor in the device subpart. In the device subpart, try to memorize this thing, because if we control the rotational motor, we can easily control the wheel. This is the main reason. So we are trying to control the rotational motor. If we can control the rotational motor by giving it all a unique name, we can easily control the rotational motor, and by controlling the rotational motor, we can control the wheels, 4 wheels separately. This is a very important part. We need to give each of the body parts of this robot vehicle a separate name. The 4 wheels should have name like wheel 4, 3, 2, and 1, and the distances should have a name. Distance sensor right, left, and middle. Now this is one of the most important part. We need to make the anchor value and the translation value similar so that the wheels can rotate properly. This is one of the most important part. We need to make the anchor and translation value for each of the wheels similar. Both of the values should be similar. Both of the x value, both of the y value, both of the z value should be similar for each of the wheels. I have completed the hinge joint. Now let's try to see the translation value for the second wheel, and by based on this value we need to change the anchor value for that wheel. So this value is 0.5 minus 0.5 minus 0.303 and minus 0.14. Now we will go to our third wheel, and at first we need to see our translation value. Then based on the translation value we need to change the anchor value. So for this wheel our translation value is 115 minus 0.03, which is 296, and minus 0.14. So for you can see each of the wheels have like different translation value, and for each of the wheels the translation value will be similar with the anchor value. But first we need to like see our translation value, and then based on the translation value we will change our anchor value. And the anchor values are default is given 0 0, so we need to change it. This is like one of the most important part. You need to like memorize this thing. If you don't like change the values properly, then your wheels will not rotate properly. Like it will rotate ups and downs, like similar to climbing a hill. The anchor points like will not be same place. Now to create the path, we are using Tinkercad. So you are going to like create a path by saving it and export it. Export this path as a OBJ file. OBJ file. Also need to like lower the height, make it like as small as possible. to want to, you can change the color and export it. It's OBJ. Like after like getting the making the path, we're like adding a code to run our robot. You need to like import a 3D model in this environment. I have like created this code. You need to like follow the steps, and I need to like add the name of the controller, which is robot LFRR. This code has been written in C++. So the name of the code and the controller and the name of the controller should be same, otherwise it won't work. The first line I have included some library. This is the path to like line to like control the sensors. After that I'm going to control the wheels, and in this part like I'm getting the values from the three IS sensors. And initially my the values of the four wheels should be -1, and in this like part I'm going to control the wheels. So we are the line, you need to import a 3D model as a robotic path. So we can see that the car is like following the line properly. Yes, try to like understand the code. At first like you need to like build the code, compile the code and run it, and reload the world to see your car moving properly. So in this video I'm trying to like give you a basic idea how to build a robot from scratch using Webot, and how to make a line by using Tinkercad, how to export it and import it, and by making by writing some line of code you can control the wheels, control the distance sensor, which will help the robot to follow the line, to keep it on the line. Yes, thank you everyone. If I have made some mistake, please mention it in the comment section, and like I will try to like improve my video quality in the next sessions. And if you want to like, you can increase the speed of the video. The rest of the video like is going to just follow the line. That's all. Thank you everyone.